Next problem statement. Let us come to the next problem statement. We have solved 11 number of problem statement. Now we'll go to the 13th problem number. We will wait for 12. We will see 12 in the next turn. Let us see now this. Pizza parlor accepting maximum M orders. Okay, M is the maximum M orders. Orders are served in first come first served basis, that is using queues. Order once placed cannot be cancelled. Write C++ program to simulate the system using circular queue using array. All right. So now what do you mean by circular queue? And first of all, why there is a need of circular queue, that we will try to understand. Now you know that if we implement it using array, let's say this is an array, and these are locations of arrays. Let's assume that. All right. Now right now the front and rear are pointing to nothing. Front and rear, the indexes, the value is -1. Let's say -1 means it is not at any location. Now if I add, let's say, the value. Okay, so how to add a value? The add value is done by using rear is equal to rear plus 1. So we'll go to the next location to add it. So r is -1, so r will now point to 0, and let's say we add the value 5. So now r is here. Now we have to add one more order, pizza order, and with, let's say, ID, the pizza ID, order ID, or let's say some ID of that, what kind of pizza the user has requested. And let's say now it is to be added, and rear moves ahead. So rear comes here, and at this location a new order ID is added, let's say 10. So r is now here. Let's say now one more order has come, and the order is now, let's say, so r will now point to this location, and let's say the order ID is, let's say, 12. Let's say now one more order is added, and let's say the order is 15, and now so it is r is pointing to this. Now we have to serve this order. So to serve the order, it is served at front location. So to serve it, we will do f is equal to f plus 1. So we'll move to the location to serve it. So f will now point to this, and this will be processed. So now f is pointing to this. Now we have to again process the order. Okay, so the next order to be processed is in first come first serve basis. This is to be processed. So front will move ahead. So front is now pointing to this, and this is removed from our orders. Now let's say a new again order has come from, let's say, SKN College, and some pizza they have ordered, and let's say the order ID is, let's say, 17. So rear is now here, and we are processing the previous order. Let's say the front is incremented, so front goes here, and it is removed. Now let's say one more order has come, so rear moves ahead, and let's say that order ID is 20, and we again process previous order, let's say, and then the front moves ahead, f is here, and it is processed. Now the next let's say order has come, and let's say the rear is pointing to this. Now it has come to end of our list. Let's say it is order ID 25, and let's say we delete let's say we process the previous order. So front comes here, and 17 is deleted. Now let's say one more order comes, but you say that it is already now end of our data structure, and there is no place to store the next order. So you say that it is full. This is full, you will say, because there is no place, place for storing the next order. So there is no place. But you see that the previous orders are already finished. These orders are already finished. So you can put a new order at this location. Let's say the new order has come, order 30, let's say. So this must be stored at this location. That is, you can, these are removed orders. And you see that this is the empty locations. But since rear is pointing to the end, you say that it is full, but it is not full. There is a place available, this place available. So you put the next order here. So it becomes like a circular. So now structure is not this, but structure is a circular. So structure is like this. So here, this is this. So this is our array, but it is this end is attached to this end. So this is, so now the array locations are, these are array locations.
Sir, we have to do this using node concept or array.
array लिंक लिस्ट से नहीं करना है, array से करना है. यहाँ पे लिखा है simulate the system using circular array, circular queue using arrays. I'll tell you how to implement it using arrays. So initially now the front and rear are pointing at the same location. Let's say the front and rear are at initial location, let's say 0. Okay, this is location 0, this is location 1, this is 2, this is 3, 4, 5, 6, 7, and the 8. So we have 8 locations. Total 9 locations from 0 to 8. All right. Now front and rear pointing at the location 0, let's say. Now we have to add the order. Let's say the order is added, and let's say order is 5, and it is added at rear location. So 5 is there, and rear moves ahead. So rear is now here, and front is here itself. So front is here and rear is here. Now a new order is to be added. Let's say it is 10. So it is added and rear moves ahead. So first the order is added, then rear is moved ahead. So rear is the location which gives the location where to add the order. All right. So that location it gives it. Now if you have to remove the order or process the order, so what it will remove the order from the this one, and front will move ahead. Okay. So front will now point to this. So similarly, what will happen that the rear will move like this, and if it is empty, so this is already deleted. So rear can take this location. Previously rear was going here and it is showing that there is no place. But now if it is connected to this place, then it is showing that there is a place and it puts it there. So this is how we will try to implement the circular queue. So now how to get the location, that is how to come from this node to this node. Let's say it is location 0. Let's say there are 10 locations. Assume that there are 10 locations. So indices will be from 0 to 9. So if my index becomes 10, then automatically it should come to location 0. Here 0, let's say there is one more location called as 9, this 9. Okay, this is 8. And now if my next location becomes 10, isn't it? If I do 9 plus 1, then it becomes 10. But it should not come to 10, but it should come to 0. How can I make it this to come to 0?
What,
Let's
sir?
say this,
You can repeat once again.
my question is, we have now 10 locations in the circular queue. This is a circular queue, all right? And this is to be implemented using array. How do you access these locations? Using indices 0 to 9. Using indices 0 to 9, you access it. Now, when my index becomes 10, there is no location, there is no any location called as 10 in the array, in the size 10. So in that case, it should come to location 0, so that it becomes a circular. यहाँ पे let's say ये 0 है index, ये 9 index है. If my rear is incremented, it will become 10, but it should not go to this next location, but it should come to this location, which is 0 location. So how do I make it?
Sir, we will use if condition. If the indices is greater than the maximum length of it, then we will again initialize it to 0.
Very good, very good. That's very good. But some better condition is also there, and that is better than this if condition. With the mathematical operation, we can do it. Can you do with mathematical operation? Instead of if else, there is no if else conditions. Just by mathematical operation, when it becomes 10, or let's say size m, size let's say m, there is a size m. If it becomes m plus 1, then automatically it comes to the location, this first location.
Sir, then we have to consider only one bit.
Okay.
Then
Can
after 9 automatically instead of 10, then it will neglect 1 and it will consider 0.
Okay, okay, that's okay. But can you do mod operation? Mod operation. How will you do mod operation? If it is my
mod 10.
If it is mod 10, that is my rear. Let's say rear is equal to rear plus 1 mod the size of the q as m. Let's say m is a size. Then what will happen? Now if my m is let's say 10, that means maximum size of the q is let's say 10, and my rear is right now 9. So what will be my rear? 9 plus 1 mod 10. So what will be the value? 10 mod 10, it will become 0. Remainder is 0. And that's what we want. So using mod operation, we can make it a circular. We can make R circular. Getting a point? So we will try to implement this part. So let us try to implement it. Let us take a new project. We will implement it using C++, and we have to implement it using array. So let us take class circular queue. Class circular queue. And we will have the how many locations? M locations. So hash define m, and m is let's say some 10 locations. Okay, we have given that what is the maximum size in this problem statement is m orders, accepting maximum m orders. So we'll have only that many orders. Okay, hash define m10. Now here we have the pizza order. All right, so int pizza order ID. All right, int pizza order ID, and let's say how many pizza order IDs can be created? M, maximum M, where M is hash defined means it's a macro processor. So wherever M comes, it will be replaced by 10. It's like find and replace. So what it will do, it will find M, capital M, and it will be replaced by 10. All right, so here M will not be there, but it will be replaced by 10 in pre-processing. Okay, so M. It is a convenient when if you have to change the M value, then you did not change in the entire program. You can change it here itself. Then it is get changed into the entire program like this. That's the beauty of using the macro processor called as hash define. Now let us take a public function, public. All right. So in the we need a two pointers, that is integer front and integer rear, right? And let us take the constructor. So constructor CQ, in which we will initialize the front and rear. Okay. So we'll have cout /n. The Q is the circular Q is successfully created, and front and rear points at same location. Let's say, and let's say front is equal to rear is equal to 0. Let's say it is the first position. Or let's take it as instead of this, we will not waste it. Let us take it a -1 space, and then if it is to be added, then we will increment the rear and then add it. All right, so that we will do it. One way, both way can be done, that it can be initialized to 0. Then in that case, first add it and then increment it. That can also be done. Or initialize is to -1, then first increment it and then add it. Can also be done. Okay, so we'll do our same, that we do it as a linked list. In the -1 means like a null, nothing. It is not pointing to anything. So we will have it as a -1. Now let us add the order. Okay, so we'll have a function add order. So add order. So to add the order, what we do typically, now here let's say again draw it. So we'll have this as a circular Q, and these are the locations. Now front and rear both are pointing to -1, that is no location. Now this is, let's say, 0th location. So to add it, what we do, first increment the rear. So rear will now become 0, and we'll add here the job. Let's say it is 12. So now to add it, and let's say the front is -1. Now we add it, next job. Let's say 15. So now rear will point to this. Now if I delete the job, so front will point to this, and this job will be deleted. Oh, sorry, this order will be deleted. So what is a condition? What is a condition for empty and full Q? Empty. What will be the condition for empty? Empty Q. You can say that front and rear, if both are equal, if front and rear, that means if I now again delete it, so front will point to this and this will be deleted. So both rear and front at the same location, and the Q is also empty. So the condition for empty is that front equal to rear. Okay, so we'll have that condition. And for add order, the another condition required is that if we go on adding the orders and there is no place to add the next order, then what will be the condition for full? What will be the condition for the full Q? Full.
Rear equal to front.
No, rear equal to front is the condition when it is empty. You may say that now let's say we add it. Now here rear is here. Okay, now we have to add it. So first you increment the rear and you add it here, rear. Then you increment the rear, you add it here. Increment it, you add it here. You increment, add it. 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 And when you increment it, you see that it is empty, but you add it here. And you see that front is pointing to this. Front is pointing to this, and some data is available. So you say that if if I increment rear, then it is pointing to F. That means if R plus 1, if R plus 1 is equal to F, means that my entire queue is already filled, because I am coming to the first location again where front is there. If my R is incremented by 1, that means if I go to the next location of rear, and if it is coming front, then it means that my job is, or my queue is full. My queue is full. So I'll have that condition.
Sir, for deletion, first we will increase. Sir.
For deletion, we will increment first. Yes. Hello.
We will increment the front first and then we will delete.
Yes.
Okay, sir.
If rear plus 1, if rear plus 1 equal to front, then what does it mean? It means that Cout /n, the circular queue is full. It is full. Else what we have to do? We have to add it, add the job, or add the order. So else Cout /n, enter the pizza order number, right? So we'll take Cin. Where to take it now? At which location? At location of the rear. So first of all, doing that, we have to do rear is equal to rear plus 1. But we have to do it as mod m to make it circular. So rear is equal to rear plus 1 mod m. M is the maximum size of the queue, so that it becomes circular. Rear is equal to rear plus 1 mod m, and Cin pizza order ID of the location rear, right? At this location, we have to accept the order ID. Now this add order is done. So now we'll have a message, Cout /n, the order is successfully added. All right. Now let's have one more function to serve the order. Void serve order. Now to serve the order, if it is empty, then we cannot serve it. So we have to check the condition if it is empty or not. What is the condition for if empty? If front equal to rear, then what we have to do? Cout the pizza orders, or the orders. There are no orders, or you can call it as the job cart is empty, or it is empty. All right. Else what we'll do? We'll delete from the queue. How to delete it? So first increment the rear front. Okay. So front is equal to front plus 1. But to make it circular, we have to again mod it by m, because we have to move the m front in a circular manner. To make it circular, it must be now wrapped around at m. So that is done. Okay, front is equal to front plus 1 plus. Why we are doing this? To make the motion circular. That is what we are doing. For this we are doing it, to make the motion circular, motion of rear circular. All right. And at this location, we have to delete the order. Okay, so cout /n the pizza order ID pizza order ID at front location is successfully served. All right, so now it is served. Done. So now we have served the order. So let us have one more function called as display various orders. Okay, so let us not write at this moment. First of all, we'll work on only this add order and the serve order, whether it is properly running or not. Just see one more thing is that in the add order, what I am doing, rear plus 1 equal to front. What if now rear is at the end? So to make the motion circular, again, we have to make it rear plus 1 mod m, so that the next location of rear, if it is the last location, should come to the first location. If rear plus 1 mod m equal to front, then it is m, then it is full. All right. So now let us have a menu driven program. So I'll take it from here, menu. Already we have implemented a menu. So let us copy this, Control C, Control V. Okay, so int choice, menu, add order, add pizza order, process pizza order, display orders. That function we have not written yet, but let us have it for exit. So let us create object circular queue, CQ object obj, and once that object is created, it will front and rear will be initialized to -1 automatically. The constructor will be called, and now we have to call with this object. Okay, so we have to call which one? Add pizza order. So which function it is? Add order. So it is obj dot add order break, and obj dot process. Why using dot? Because it is not a pointer. Okay, obj is an object, it is not a pointer, therefore we need to use dot operator. If it is a pointer, CQ pointer obj, then we will have to use the arrow operator. Okay, remember this, obj dot serve order, all right, break, and then obj dot display orders. But right now we don't have that function, so I'll comment it out. Case 3, case 4 is exit, default, enter the proper keys. Okay, so now let us run it. So 64 line, we are in having an error. 64 while, okay, it's a while, that is okay. Return 0 is in here, while, then return 0. Actually it will not be executed, and the program is finished. Okay, now so add pizza order. First of all, we'll have process pizza order. Right now it is empty, so it should show that it is empty. So there are no order, it is empty. Now we are correct that which it is. Now let us add a pizza. Okay, so pizza is added with order, let's say 1. It is successfully added. Now let us add one more with order ID 2. Successfully added. Okay, now let us add one more with order ID 3, let's say. And now let us delete the process, the pizza. Let us process it. So the pizza order ID 1 is successfully served. Now let us again process it. So the pizza order ID 2 is successfully served. Now again process it. So the 3 is successfully served. Now if I again write 3, so it should show that it is empty. All right. So is it showing empty? Let us see it. Yes, there are no order. It is empty because it is now same. Now we will add the again pizza order. So 1 add. So let's say enter the pizza order number 1, and we will add 10 orders, let's say, and it should show that it is empty. Sorry, it is full. Okay, so we'll add it. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I add it, now here the circular queue is full. Okay, so that means we are now successfully added 9 orders. Now for 10th order we cannot add it, because if we add it, then front and rear will become equal, and that will go to the condition as empty, but it is not empty. So our in circular queue, one location will not be able to, we will not be able to utilize it. Okay, so this one location we will not be able to utilize it if this entire thing will be finished. Okay, this entire location we can utilize it. And then so if there are 10 locations, then we can utilize 9 locations into circular queue. Now if I remove one by one, okay, let us process the order. So 2. So first,
Sir, why we can't access the 10th?
We cannot access the 10th because see here.
Sir, we have started from 0 ना.
हाँ, मैं बताता हूँ आपको, बताता हूँ. Let us see it. क्यों नहीं कर सकते हम? Let us assume that there are some few locations. Okay, so this is a queue. Okay, right now let's say these are our locations. These are our locations. Okay, right now front and rear are -1. All right, so now I add it, the job. So what will happen, that the rear will now become 0. Okay, let us take this location as 0, this location as 1, this is 2, this is 3, this is 4, and this is 5. Okay, now rear becomes 0 and it will be added here. So let's say the job or the order ID is 5 is added. So this is filled. Now if I delete, let's say one more thing I added, let's say 10. And now rear is pointing to this. And front is right now -1. Now we have to delete the order. So this will be deleted. Okay, so here this is a location. So front is now pointing to this. Front is pointing to this, rear is pointing to this. Now if I add one more, 15, so rear is pointing to this. Now add one more, so rear is pointing to this. Now add one more, so it is pointing to this. Rear, now again add one more. Okay, so here let's say 30, so rear is pointing to this. So now if I try to add, now this is empty location, this is already deleted, this is deleted, this is empty location, and front is pointing here. Now if want to add one more, then what will happen, that rear will go here and it will go, let's say next order ID 35 to be added. Now there is a place, but what will happen, that rear and front will now again point to the same location, and it is a condition that it is empty. But do you see that it is empty? No, it is not empty. So then we have to keep this position not filled, so that we can clearly distinguish between the two cases. The first case is that empty, and the second case is full. What is the condition for empty? When front is equal to rear, then it is empty. And what is the condition for full? When rear plus 1 is equal to front, then it is a full. Getting a point? This is a rear and this is a front here. If I do rear plus 1 equal to front, that means I come to the front location, then it is a full. So that's why we will not be able to utilize this place. If we utilize it, then our entire queue will become empty. All right, so that is the case. You got it? So we have successfully implemented a.
Yes, sir.
हेलो सर
हाँ बोला ना.
सर वो रियर प्लस 1 इक्वल टू एफ वाला नहीं समझा सर.
रियर प्लस 1 ये क्या? अरे
हाँ
आप पेपर पे कीजिए मेरे साथ तो आपको समझ में आएगा. सिर्फ देख के नहीं होगा. यू डू विथ मी. मैंने ये क्यों निकाला ना, आप भी निकालिए पेपर पे, आप भी उसमें डालिए. जब तक आप खुद वर्क नहीं करेंगे वो पता नहीं चलेगा आपको कि फ्रंट अब ऐड कैसे हो रहा है, वो कैसे डिलीट हो रहा है. तो वो जब आप खुद करेंगे ना उसमें समझ में आ जाएगा. अब मैंने क्या किया, यहाँ पे रियर से पहले मैंने इंक्रीमेंट किया तो रियर यहाँ जा रहा है, फ्रंट यहाँ पे था. ओके, सो रियर यहाँ से जा रहा है. ओके, रियर यहाँ पे आ गया. तो मुझे यहाँ पे आइटम डालना है. तो इफ आई डू रियर प्लस 1 इज इक्वल टू एफ, दैट मैं रियर प्लस 1 करके एफ ये लोकेशन पे आता हूँ, ये लोकेशन पे, तो इट मीन्स माई क्यू इज फुल. So that is what is that condition. If rear plus 1 mod m equal to front, then it means my circular queue is full.
Okay sir, got it.
Thank you. Now so that's the अब इसमें क्या करो, आप सिर्फ इसमें डिस्प्ले फंक्शन लिखो. डिस्प्ले में सारे पिज्जा ऑर्डर्स दिखने चाहिए. मैं ये कोड आपको देता हूँ. Just write one more function. I'll just write a prototype of it. Prototype of the function. Let us write a for exit. Now you have to add one more function, that is void display orders. And so what you have to do? Write code for displaying entire orders. That is from front to rear. Okay, so you have to start from front and till rear you have to go, and you have to display all the orders one by one. Okay, so just that function you have to write it and complete this.